Alright, so today we're going to worry about some vector additions that happen to occur at 90-degree angles. Now again, many of these situations or scenarios are incredibly silly simply because it's challenging to find exact situations that fall into this 90-degree angle scenario because most things in life will not occur as simply as that, but that would require some pre-calculus for us to solve, and we're going to ignore that. Anyhow, in terms of our first problem, we are going to start off with a runner traveling 8 meters to the north, and they turn and they brake 5 meters to the west. So we'll start off with our 8 meters to the north. Nice little vector going that way. Label it 8 meters. There you go. To the north. And then we happen to turn and travel 5 meters west. So that's going to be 5 meters this way. 5 meters. So it tells you to draw the vectors head to tail. Just did that, head to tail. Obviously this vector is going to come off the head of the other one. And solve for the resultant displacement. And what that means is we are basically going to solve for this thing. And this is your resultant displacement that we are trying to solve for. In any case, the way that we set this up is a nice little Pythagorean theorem. A squared plus b squared equals c squared. It doesn't matter which we start with, so I'm going to start with a is 8. 8 meters. And we're squaring that guy. Plus 5 squared. And we'll throw a c squared in there too because we like finishing off the equation. 8 squared is going to give us 64. Plus 5 squared gives us 25. And again, we still equal c squared. 64 plus 25 gives us a nice little 89 equals c squared. And at this point, because of the c squared, we've got to figure out how to unsquare c to get a real number here. So we're going to take the square root of 89 and the square root of c to end up with c equals 9.43, and again our units were meters and meters. But I guess the other thing we need, because we're talking displacement, I need a direction. And the direction is obviously going to be north, west. Okay, so north, west. Our second example is going to revolve around things that are foreign to you southern children. Hockey, and that's because there's a whole lot of ice, and well, let's be honest, if it freezes down here, things shut down. In either case, our hockey player is moving 4 meters per second to the north, and then turns right to go around a defender. So we're going to start off with 4 meters per second here. 4 meters per second, and then he's going to move 6 meters per second to the east. So 6 meters per second this way, 6 meters per second, and again, as we know about vectors, the length of the arrow actually matters. So we'll notice that this 6 meters per second arrow is a little longer than the 4 meters per second arrow. Again, we're going to draw the vectors head and tail and solve for the resultant velocity. So this thing is going to be what we solve for. That's a resultant vector. And we're going to solve for that again using our a squared plus b squared equals c squared. In terms of our a squared, we'll go and use our 4 squared plus our 6 meters per second squared produces c squared. 4 times 4 gives us the 16. 6 times 6 gives us a nice little 36. My pluses aren't working. And I still get a c squared. 16 plus 36 gives us a nice little, what we got, 52. Or c squared. And again, because we have a square here, we're going to take the square root of this whole thing so that we do not have that squared sign, and we're left simply with c, and our resultant is going to be a 7.22, or 7.21, sorry. And again, our units here are meters per second. Meters per second, meters per second. But again, we need a direction, and that's where our north and our east come into play. So 7.21 meters per second, northeast. And moving our way down to the final question, this is definitely as complex as it gets. We're going to talk about a dog chasing a ball. So in this example, the dog chases the ball south for 5 seconds. So we've got a south for 5 seconds, and that's 30 meters in 5 seconds. And doing a little bit of quick mental math, 30 meters in 5 seconds, displacement divided by time ends up giving us 6 meters per second for an actual velocity there. The dog catches the ball and turns east and runs another 20 meters in 3 seconds. So we drop this guy, nice little arrow there. We're traveling 20 meters in 3 seconds, and this will produce us with a nice little 6.67 meters per second. Doing a little quick math in the head. And essentially what we've got to do, draw the vectors head to tail, did that, solve for the velocities, did that, and solve for the resultant velocity. So we are going to work our way to the point that we can solve for that. And we're going to call that our resultant velocity. So again, for the final time, a squared plus b squared equals c squared. And we know that 6 squared plus 6.67 squared equals c squared. We actually apply the squares to each of these. This becomes 36 plus 44.49 equals c squared. Add those two together and we end up with 80.49 equals c squared. And as always, we throw a giant square root over everything to get rid of that 2, or the squared, sorry. And when we end up square rooting that, what we end up coming up with is this c, or the resultant, is going to be equal to 8.97. Again, our units here are going to be meters per second. And in this case, we need to come up with a direction. We definitely had south and to the east, and as you see, southeast, your drawing should match up with that. Southeast. Obviously, if you can work your way through these, I can't imagine that you'll struggle with any other vector addition problems that I'll give you, because we will never do anything that is not this 90-degree angle. For instance, I will never draw you something that says east and then northeast. That's a big no-no in our book. Anyways, have a wonderful day, kiddos.